Hello everyone. This is an exciting video for me. I just get to solve some math problems. So just follow along as best you can. I'll give you some tips that will help you get a little better at solving application problems from Chapter 6. All of these problems appear in Chapter 6.5 of your textbook. If you wanted to try these first, I recommend that you do so. So I've included a link on the bottom that will link to the questions that you can try. Try all these out, and then once you've tried them, come back and watch the rest of this video. So the first question here, what we have is, and I'll just get out a highlighter for us, and so that we can track the important stuff that's in the question. We have a firework that's launched upward at an initial velocity of 49 meters per second from a height of 1.5 meters above the ground. The height of the fireworks in meters is modeled by this equation. And probably this question is just going to deal with this equation because it already did the hard work of making that equation for us. It asks us what the maximum height of the firework is above the ground. And so we know that our x, let me just change this back to a pen. So go back. We know that our x values are all times in seconds. Okay, and all our heights are measured in meters, and those are our y values. So it gets launched at 1.5, so that's going to be our y-intercept. And not surprising, it's c in standard form. And so we're going to get something that looks something like that. Now this is where the height's 0. So the only place that this is sort of a valid graph is right here, right? Anything below the line would be below the ground, and that doesn't really make sense for a rocket. It's asking us for the maximum height. So the maximum height looks like it's right there. And we'd only want the y value there. So the y value here is a maximum height. Now how do we get a vertex? That's a vertex. From standard form, well, you got to change this to vertex form. And how do you do that? You complete the square. And so I just put the equation over here on another page. And we're going to use that now in order to complete the square. So remember, our goal is to have something that looks like this in the end. A times t minus h all squared plus k. I've just used h and t instead of y and x because we have h and t in the equation where y and x were in our original standard form. So you'll notice that the first thing you need to do is you need to get this a out of the bracket. Okay, so let's do that. Minus 4.9. We have to leave the t inside the bracket. T. Now what do you have to multiply 4.9 by to get back out this 49t? Well, it'll have to be minus, because minus times minus gives you positive. And it looks like 10, minus 10 t. Okay, that was t squared. And we leave this 1.5 outside the bracket because we have k in our original, or in our goal, our vertex form, which is our goal. Now, hopefully this is somewhat familiar for you now. We're just going to take half of this and square it, which will give us 25. And that's going to be our tack-on number. So minus 4.9 t squared minus 10t plus 25 minus 25. You have to effectively do nothing because you can't change the value of the equation. And 25 minus 25 is 0. All the rest we've just left the same. So the step here is just to figure out what number we're going to put there. Okay, now those three terms there make a perfect square trinomial, and we can factor that. That becomes t minus 5 all squared. We have to take away 25 and plus 1.5. The end. Now all we have to do is redistribute this in. Okay, and we get minus 4.9 times t minus 5 This is going to be squared and plus. So this is 5 times 25, which is 125, minus 0.1 times 25, which is 2.5. Okay, so when you do the subtraction there, you get plus 122.5, and we still have to add 1.5. So altogether, minus 4.9, t minus 5, all squared, plus 124. So that makes the vertex now that we have in vertex form, we can just read it off, is equal to 5, 124. Okay, so now we can state what the maximum is. The max height is just the y value of the vertex. We talked about that. So the h value of the vertex in this case, which is 124 meters. And you should write a therefore statement. Therefore, the maximum height is, and you can write that out yourself. Okay, so we've done this one. And we go back here. Over what time interval was the height of the firework greater than 100 meters above the ground? Round to the nearest hundredth. Okay. So let's just go grab that equation again, just so we have it right in front of us down here. Okay, let's grab it. We'll move it down here. And so for B, we need to know the time interval when it's above 100. So again, we know that we're here. We have actually a little bit more detail now. We know that this is 5 seconds in. It's at its max height of 124. So you can go up and down. Okay, it's going to hit the ground there. So somewhere in here is 100. And we want to know how long a time that is. Okay, so it's clear that the height here for both of these cases is 100. So let's just let h be 100, and now we find out the consequences of that. So 100 is equal to minus 4.9 t squared plus 49 t plus 1.5. Now what we have to do is rearrange this so that it looks like this. ax squared plus bx plus c equals 0. And in our case, it'll actually look like this. At squared plus bt plus c equals 0. Because if we have a, b, and c here, we're able to put it into the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. And that will allow us to find the value of t, which is what we're looking for. In this case, 2 values. Then we just have to find out how the distance or the time in between them, how long the time in between is for those. So in order to do that, I'm just going to add all this stuff to this side. So 4.9 t squared minus 49, get rid of that decimal in there, it doesn't belong, 49t, I'm going to subtract 1.5, which makes 98.5 equals 0. Okay, so now when we take a look at this, A, B, and C. So I will write out what this looks like, and you can, as an exercise, solve what t is. So t is equal to minus b, which is going to be 49, because minus minus gives you positive, plus or minus square root of 49 squared minus 4 times 4.9 times 98.5. You have to divide that by 2 times 4.9. You're going to get 2 answers. The reason you get 2 answers is because of that plus or minus. And just be careful at the end. It wants the interval, meaning you're going to have to figure out one answer and the other answer and figure out the change between those 2 times. Okay, so figure out the difference between the 2 times and you'll have your answer. I'm going to post the rest of the solutions in separate videos, so keep an eye out for those.